Okay, I'm back. I took a lengthy lunch break, so now I'm well fed. I'm ready to finish up this final exam review. For number 25, so what we have here um, is a polynomial equation we need to graph. The key thing here is to identify the leading coefficient. So don't FOIL, but try to figure out what the leading coefficient is. So if you were to work it out, you have negative 1/3, you have x squared with a whole bunch of other junk, and x plus 1. So it seems like you'd have x cubed after you FOIL again, or multiply again, with a whole bunch of other junk. So that's your leading coefficient. We have a negative, or actually figure out what the leading term is. Let me rephrase that. I want to figure out what the leading term is. So the leading term is negative 1/3 x cubed. So you have a negative leading coefficient in an odd degree. So what that indicates is that the arrow is going to point like this. So always the leading coefficient determines how the ends will behave. So when x gets really big, y is going to go down. So f of x approaches negative infinity as x approaches positive infinity, and y is going to approach positive infinity as x approaches negative infinity. So when x gets really small, we expect y to point up if we were to work all this out. So we expect the arrows to look like this. And then also we notice that it's going to cross the x-axis at negative 1. Your zeros for this function, if you were to set y equals 0 and solve for x, would be negative 1 and 3. But there's a bounce at 3. It is why there's a bounce is because there's a square there. So if we were to work it out, let me fix that. So if you have your x-intercepts, and also if we look at where our y-intercept would be, if you put in 0, you would get negative 3. So that would be your y-intercept. So the graph will look something kind of like this. And the reason why there's a bounce why a bounce? And that's because if you do a sign chart, which actually I'll open up another window right now. If you do a sign chart, again, our zeros are negative 1 and 3. And if you test various points, like negative 2, 0, and 4, and remember, here's our equation. Y equals negative 1/3 x minus 3 squared times x plus 1. If we were to plug in negative 2, we get negative 2 minus 3, which is negative 5. Negative 5 squared is 25. But then times negative 1/3 makes it negative. Then if we plug in negative 2 plus 1, we also get another negative. So altogether, it'll wind up becoming positive. So it's positive here. If you plug in 0, we get 0 minus 3. Negative 3 squared is 9. Negative 1/3 times 9 is a negative value. Times 1 will still stay negative. If I type in 4, or punch in 4, 4 minus 3 squared is 1. Times negative 1/3 is negative. Then times 4 plus 1, which is 5. Negative times 5 is still negative. So if you do a sign chart, you would notice how at the boundary where x equals 3 at one of the zeros, y is still going to stay negative if you were to plug in these values like -2, 0, and 4 into the equation here. So that's why we have a bounce when it has an even degree connected to the factor. So that's something that's good to know. I won't ask that on the final exam, but I will ask that next semester, so definitely will look into that. But that's why we have a bounce. So here's the other one. Now I can just do this one probably a little more quickly. Negative x squared x4 plus negative x plus 1. Negative x squared, you have negative x5 plus a whole bunch of other junk. Then when you distribute, you wind up getting x7 plus a whole bunch of other junk. So the end behavior, this time we expect to be down up. Odd degree, positive leading coefficient. So when x gets really big, we expect y to go up. Fx approaches positive infinity as x approaches positive infinity. And f of x approaches negative infinity as x also approaches negative infinity. And hold on one sec. Did I make a mistake here? No, I got it right. So we know the arrows are going to look like this. The zeros are at 0, -2, and 1. For the first two zeros, we'll have a bounce because they have even degrees. So we have -2, 0, and 1. So it hits -2, bounces off of it, kind of dips down a little bit. We don't know how far it dips down, but it's going to come back up again. Hits 0, bounces off again, then passes through. The y-intercept, by the way, is 0 here. If you plug in 0 for x, you'll get 0 for y. Okay. You'll definitely see problems like 27 and 28. Now, if you can't look for factoring, if factoring can't be done, then what we do is do the whole P and Q business, find the rational zeros. The possible rational zeros of 26, the leading coefficient, are plus or minus 1, plus or minus 2, plus or minus 13, plus or minus 26. And the leading coefficient is plus or minus 1. We'll start by trying out 1. Keep our fingers crossed that it works. Okay, let's try 1, 1, 1, -6, -6, 21, 21. Oh, cool, it works. Now 1 could work a second time. So now we have our new polynomial, which actually is going to happen to be x cubed minus 6x squared plus 21x minus 26. If we try 1 again, nope, no good. We try -1. Nope, no good. Let's try 2. Well, that works. So 1 and 2 work. And this represents x squared minus 4x plus 13. Now you could do the the synthetic division again, or you can just use quad form by hand. So we do it by hand, we should get the following answers. And I'll let you do that on your own, but you should get 2 plus or minus 3i. And then 28, again, look for factoring if possible. And fortunately, we can factor here. We don't have to do the P and Q thing. It'd be kind of crazy if we did for this one. And by the way, the constant term is 0, so I'm not sure what else you try besides 0 if you did the P and Q thing. So you could have done it that way, I guess. But so set the equation equals 0 because we're trying to find the zeros. Factor out 4x. You have x4 minus 3x squared minus 4. X squared minus 4, x squared plus 1. Set each factor equal to 0. You should have 0, plus or minus 2, or plus or minus I. That's because if you set x squared plus 1 equal to 0, x squared equals negative 1, and when you square root, you got to put plus or minus, and because I is the square root of negative 1, we say plus or minus I. And likewise over here, if you have x squared minus 4 equals 0, x squared equals 4, x will equal plus or minus 2 after you square both sides. 29, simplifying exponents. Try to respect order of operations. So PEMDAS. So clean up the inside first. Don't try to get too fancy here. 5 over 25 is 5. X over x squared is x. Y7 y4 is y cubed. So notice I subtract the exponents, and I do simplify 5 over 25. The second set of parentheses, really nothing to clean up there. Now do the exponents. X cubed, y9, 5 cubed, x negative 2, y negative 6, 5 negative 2. Because you have negative exponents, we should flip them. And then we can do the division, which is basically, or if you want to multiply these together, you get 25 x cubed y9, 125 x squared y6. Then do the division. 25 over 125 is 5. X over x2 is x, y9 over y6, y3. And so that's your answer. For 30, the way I like to do this problem is the following. If negative root 2 is the solution, then you need to have x being equal to plus or minus root 2. Because remember, we want rational coefficients. If you just have root 2 as a 0, you're going to have a problem. Because then you're going to have irrational coefficients when you try foiling it all out. So you need to put plus or minus root 2. And here, x equals 3 plus or minus 2i. Square both sides, and move that over. So that's going to be, so it's kind of working backwards. That's what we essentially had. We had x squared minus 2 somewhere along the way. If we were given the equation to how to solve, that's what you would have. Here, x minus 3 equals plus or minus 2i. Square both sides. Move negative 4 over. So you have x squared minus 6x plus 13 equals 0. And then we multiply these two together. Work it out. x4 minus 6x2 plus 13x squared minus 2x squared plus 12x minus 26 equals 0. x4 minus 6x cubed plus 11x squared plus 12x minus 26 equals 0. So that's our polynomial right there. Okay, I'll stop the video and I'll make one more segment.